Hello. In this video, we will investigate the unit circle and how it can be used to evaluate trigonometric functions. First off, we start with a circle centered at the origin of a coordinate plane. By measuring angles that initiate on the positive x-axis, we would see the following angle measures. Could you predict the remaining angle measures? Pause the video now and try to find the others. You likely noticed that the primary angle measures are labeled in increments of 15 and 30 degrees, and the last measurement is 360 degrees, which indicates a full rotation. We referred to the angles of a unit circle measured in degrees initially, but the same measurements can be reported in radians as well. The radian unit of angle measure refers to the distance around the unit circle rather than the pi-like subdivision of degrees. The radian measurements are as follows. While the angle measures in terms of pi may seem unusual, there are many ways to memorize them which can be done at another time. You can also spend time researching the values and how they were derived from the circumference of the unit circle. These angle measures are important for us when evaluating trigonometric functions, since we must rely on the angle measures as inputs to our trig functions. The outputs, or results obtained by trigonometric functions, are side length ratios, which correspond to the coordinates we label on the unit circle. Each of the points labeled in the first quadrant are repeated, sometimes with sign changes around the rest of the circle. Here they are. In a similar way to radian measures, these values can be memorized, or you can learn to derive coordinates by considering the triangles associated with each angle measure. Take, for example, the 60-degree, or pi over 3 radians angle measure. A right triangle is created by using the angle, the x-axis, and a line perpendicular to the x-axis through the point of intersection on the unit circle. When we consider the definitions of sine, cosine, and tangent, we see something interesting. Sine of an angle measure is defined as the opposite side length divided by the hypotenuse, whereas cosine of an angle measure is the adjacent side length divided by the hypotenuse, and tangent of an angle measure is the opposite side length divided by the adjacent. Since the side length opposite of the angle measure is the same as the y-coordinate of the point, and the adjacent side length is the same as the x-coordinate, we can rewrite these trig definitions this way, since the hypotenuse of each triangle is equal to 1. The resulting trigonometric calculations are found simply by identifying coordinates within the unit circle. This works for all angles of the unit circle, not just those in the first quadrant. Perhaps now you can see why some people spend some time memorizing the components of the unit circle. Let's try some examples. In problem number 1, we must find sine of pi divided by 3 radians. Since sine is associated with the y-coordinate, we can simply look at the position in the unit circle to see the square root of 3 over 2. In example 2, we must find cosine of 135 degrees, which requires the x-coordinate. So we will say the result here is negative square root 2 over 2. For tangent of 300 degrees, we must divide the y-coordinate by the x-coordinate and simplify. Should you encounter a fraction with a radical in the denominator, it is good practice to rationalize the denominator as you simplify. In this case, however, we simplify to the opposite of the square root of 3. Please pause the video now and try the last 3 on your own. Resume playback in a moment to check your work. I would say that examples 4 and 5 were pretty straightforward. In number 6, however, we had a y-coordinate of 1 and an x-coordinate of 0. A y-coordinate of negative 1. Please remember that a fraction with 0 in the denominator is undefined. Therefore, tangent evaluated at 3 pi over 2 radians, or 270 degrees, is also undefined. I hope these examples help. Feel free to practice finding more results on your own. You can check your work with a calculator. However, most calculators will return results in decimals that must be rounded rather than precise solutions we obtained here. Good luck.